Welcome to the first lesson in the tutorial Introduction to Machine Learning. Here's for the introduction. Some questions you might have coming into this. What is machine learning? What role does machine learning have in high-energy physics? And what should I do if I want to get good at machine learning? So our objectives for this lesson are to discuss the general task, provide examples of machine learning in high-energy physics, and give resources to you people who want to become proficient in machine learning. So what is machine learning? It's the field of study that gives computers the ability to learn without being explicitly programmed. The simplest example of machine learning is trying to fit a line to some data, and you may have already done this before and may not have known you were doing machine learning. There are three main tasks in machine learning. One, regression. For example, the input might be height and weight, and the output might be resting heart rate. Two, classification. For example, we've got two different classes, roses and begonias. The input would be images, and then we may assign the integer 0 and 1, 0 to roses and 1 to begonias, and classify which of those a particular flower falls into. And number 3, generation, where the input is noise and the output is something sensible. So what role does machine learning have in high-energy physics? First example, one may want to classify detected particles as signal or background based on a number of properties, energy, momentum. The second example is in my research, I want to make measurements of a rare signal process. Background processes that look similar to the rare signal process are much more common. Therefore, a machine learning technique can optimize at the same time the use of many variables that separate signal and background. Not only does a machine learning technique optimize the use of many variables at the same time, but it can find correlations in many dimensions that will give better signal background classification than individual variables ever could. Again, this is classification, and similar to what we'll be exploring in this tutorial. Machine learning has become quite popular recently. Here is the number of papers available in the artificial intelligence section of arXiv up to 2018. It's been increasing rapidly. Here you can find a few recent articles on machine learning in high-energy physics. And last section is where to become proficient in machine learning. It's important to say it's not something you'll learn in an hour. It's a skill you need to develop over time. Ideally, practicing a bit every day. If you really want to excel, I would recommend trying an online course such as this one linked here, or if textbooks are your thing, you can try this book. Whether you do online course or textbook, make sure you code along with each part. Don't go crazy. 30 minutes a day is already very good. Be surprised how much you could learn in a couple of months. For learning essential Python libraries, you can try this online article linked, or this textbook if you have it. And for learning machine learning libraries, you can try this article or this textbook if you have it available. For a bit of perspective, I started learning about machine learning in April 2019. So don't expect it to be quick, just follow online courses and code along with them. That's it for this first lesson introduction. The key points have been that the three main tasks of machine learning are regression, classification, and generation. That machine learning has many applications in high-energy physics, and if you want to become proficient in machine learning, the bottom line is you need to practice. See you in the next video where we discuss the mathematical foundation.